There are two different pipe bursting methods, dynamic and static. When dynamic pipe bursting is being applied, a pneumatic hammer or ramming machine is propelled through the old pipe with the assistance of a winch which performs the actual pipe bursting operation, whilst simultaneously pulling in the new pipe size for size, or upsizing of existing pipelines is also possible. A hydraulically driven static pipe bursting rig pushes the quick lock rods up to 200 meters into the internal line of the old pipe. On arrival in the target pit, the bursting tools with the new pipe are connected. While the rods are being pulled back in, the old pipe is fragmented and displaced, and a new pipe of equal or larger pipe diameter is pulled in at the same time. Under favorable conditions, the rods can be pulled back through the rig and simultaneously pushed into the rear-facing mains, ready for the next bursting operation. A highly productive solution. The time needed for the rod string assembly and disassembly for an entire two-way mains replacement length is thus saved. House connections can be installed or replaced directly from out of the pit or the manhole to the interim pit without open trenches. Some sewer lines are made of brittle materials like vitrified clay, concrete or grey cast iron. In such cases, a bursting cone and sleeve is utilized, which shatters the defective pipe into small shards and displaces them into the surrounding soil. Materials which are hard to break, for example steel, ductile cast iron or plastic, are cut open with a cutting or roller blade and pushed apart.
Installation of the pilot tubes on line and grade. The 4-inch pilot tubes are pushed through the ground from the launch to the reception shaft. The leading end of the pilot tube is the angled tip steering head. This head holds the LED illuminated target that is visible through a theodolite, camera, and monitor. The theodolite and digital camera are set on the desired line and grade and positioned to view the target through the center of the pilot tube. The crosshairs of the theodolite are visible on the monitor along with the illuminated target. The operator rotates the steering head as needed to maintain the desired line and grade. By using a computer monitor and digital camera to view the output, the signal can be digitally enhanced, allowing for an extended run. This guidance system has ensured line and grade tolerance of 1/4 inch in distances exceeding 500 feet. The dual-walled pilot tubes provide a means to lubricate the outside of the tubes as they pass through the ground, which reduces the force required to thrust and rotate during installation. Diameter by following the pilot tubes with a reaming head that matches the diameter of the final product pipe. The reaming head and temporary casings and augers are attached to the pilot tubes and advanced by the jacking frame. As the temporary casings advance, they push the pilot tubes into the reception shaft, where they are removed. Spoils are removed and transported by the augers back to the launch shaft and fall into a dirt bucket, which is emptied when full. Step 3 is the installation of the final product pipe. A pipe adapter is installed on the last section of the temporary casings and augers to match the final product pipe. Just as the temporary casings and augers replaced the pilot tubes at the receiving end, the final product pipe pushes the temporary casings and augers into the reception shaft where they are removed. The process is finished when the product pipe reaches the reception shaft.
PIPP is a pipe within a pipe, installed without digging. Resin-saturated, coated felt tubing is inverted or pulled into the existing pipe. Hot water or steam is then circulated throughout the tubing, curing the resin and forming a tight-fitting, jointless, corrosion-resistant pipe within a pipe. Service laterals are then restored using a robotically controlled cutting device. Finally, the rehabilitated pipe is fully inspected by closed-circuit TV.
Let's rewind and take a look at the directional part of the drilling. The impressive accuracy of horizontal directional drilling is achieved through careful planning, well-trained navigators, guidance software, proper setup, and advanced steering tools. A skilled driller can direct the course of the drill bit along a pre-planned path over great distances. Different formations, however, require different techniques. In alluvial or soft formations, a jetting assembly uses high-pressure fluid to remove formation while drilling. The steering tool transmits data to the navigator. The driller can now orient the bend and the hydraulic pressure toward the desired direction. The nozzle, aligned with the bent sub, focuses intense hydraulic pressure to a chosen direction. It's like holding your thumb across a garden hose to increase the spray. Pushing forward, the bit follows the path of least resistance, guided by the deflection of the bend. Once this directional adjustment is complete, the driller can go back to rotating the drill string. Harder formations require a different approach. A drill motor replaces the jetting assembly. Now the hydraulic pressure is used to drive a turbine, which rotates the bit without having to rotate the drill string. This allows the driller to orient the bend and drill in the desired direction. The string is pushed forward or slid, guided by the deflection of the bend. Once this directional adjustment is complete, the drill string can again be rotated. At regular intervals, steering data is gathered and adjustments made.